Algebra in big question is a little bit hidden, kind of way. Now, if we are looking at this question, it seems about volume and area, but actually it's not. It is about algebra. Let's see. A cone has a radius of r and a height of h. The curved surface area of the cone S can be written as, and we are given a formula. Rearrange these to write h in terms of s, r, and pi. What does that mean? That I need to have h on its own and the rest of the stuff on the other side of the equation. And then they are telling us what form, where should we go, that this is where you are going, that's how your answer should look like. Okay, so first let's focus on moving things around. I'm just going to write this thing again here so that we can work. So where is our h that we want? Well, our h is under the square root, isn't it? So that is all together. Now, I have that square root is multiplied by pi and r, and then I have a number here, or as a letter. So first thing I can do, I can eliminate this pi and r, because I need to start a process of elimination. How do I eliminate multiplication? By dividing and dividing both sides of the equation. So on one side, I have s divided by pi multiplied by r, and on the other side, I have the square root. And on the 8r squared plus h squared. How do we eliminate square root? Because we want h on its own, power of 2. But if I take one side to the power of 2, I have to take the other side to the power of 2 as well. So that means I have s to the power of 2, I have pi to the power of 2 multiplied by radius to the power of 2, and on the other side I have r to the power of 2 plus h to the power of 2. Okay, so we are kind of getting there. Next thing, that r has to go. That's simple enough. I take that r to the other side and therefore change the sign to the opposite. So from positive become minus negative, minus r to the power of 2 equal h to the power of 2. Last thing to eliminate is what? That power of 2. So how do we do that? We take a square root of the other side of the equation. Now, that is all good. We've achieved the first part. We have h equal. Now, the problem is, where am I going with this calculation? So they are telling me, let's get that here so that we can see it. This is how my answer should look like. And in situation like that, how do we do it? Well, sorry, that n isn't there, so we don't get confused. We spot the difference. What's the difference between what we have and what they have? Well, all the answer there is one fraction. We have a fraction minus a number. So first thing I need to do, I need to get one fraction under that square root. How do I get the same one fraction? I need a common denominator. I lost power of 2 here. How do I get common denominator? Well, here I have a denominator of 1. I multiply them. Isn't it? So if I multiply that 1 by pi square r square, I have to actually do the same on top. Oh, that's going to be really high power, isn't it? Because we are getting to now r to the power of 4. Okay, and let's not forget our square root. Okay, so now let's write it as one number on top here, so that again we can be considering what we have and what they have and how do we get there. Let's take our, okay. So we have now one fraction that is achieved. Then we are looking at the square root. They have the square root on the top of the fraction, not at the bottom. So what can we do? Well, when we have a fraction under the square root, we can take the top of the fraction under the square root and then the bottom of the fraction under the square root. So let's apply that. So if I take the top of the fraction and then the bottom of the fraction under the square root. Now, what happens here at the bottom is interesting. So when I have two numbers that are multiplied by each other under the square root, I can divide them. That's the first thing I can do. So let's do that. I am breaking it down bit by bit. You don't have to do it in each step like that, but I just want to make sure you understand what I'm doing. Oh, I forgot the square root here. Now, when we have a number under the square root that is taken to the power of 2, or the other way around, the whole square root can be taken to the power of 2, it will equal that number, okay? Because basically they get cancelled out. So here, that means whatever I have on top of the fraction, oh, that should read power of 4. I keep writing the wrong stuff. Okay, so that means that power of 2 and a square root will eliminate. So this is what we have. Okay, so now let's consider again our terms and condition. Where is our... Okay, so I have R, so that's checked. Then I have B, I have pi. Then I have A, and I have pi to the power of 2. Then I have R, check. S to the power of 2, correct. So here I have 4. So the question is N, A, and B, how are they described? Because my A is pi to the power of 2. My N is 4, and my B is pi. So let's see how A, B, and N are described in our question, where A, B, and N are constant. What that means, they are numbers. So yes, we fulfill the condition because pi, let's not forget, is a number, isn't it? So I have a number, have a number, have a number. So yes, we fulfill the condition, terms and condition of the answer.